Assalamualaikum warahmatullahi wabarakatuh. Today we will learn about a vector space, which is previously actually we have to know about introduction to vector before we start to vector space, because it will be related to the property of a vector space. But today we will start to learn about the vector space and its properties or axioms. Wait a minute. Okay, we'll start by the definition of the vector space. The definition of vector space is the set of V capital together with an operator called vector addition and another operation called scalar multiplication. So actually we have two basic operations here. It is the vector addition and the scalar multiplication by following the property of axioms of the vector space. Okay, and the vector addition means here that a rule for adding two elements of V to obtain a third element of V capital is the meaning of the vector addition. And the scalar multiplication here means a rule for multiplying a real number times an element of V to obtain a second element of V. So that is the basic definition of vector space. And now we will learn about the property of the vector space. Actually, we have 10 properties. Yeah, so the properties have we have 10 properties, and you can look at this from the number 3 to number 10. It's actually the basic property of the vector operation. But we have two addition here, adjustment here. That the first is for addition and the second is for scalar multiplication. I just use it dot. And we will explain it one by one. From the first properties, that is U plus V, it has to belong to or in a field of a vector space, and we call it as a closure property of addition. So closure property of addition. So if you have any U, number of U or V, it has to be it can be operated by the multiplication, and it cannot change the result of this U plus V, or it has to be the same like this. And we will show you in the example to help you understand more about this. And the second one is AU. AU is also have to be the set of the vector space, or it have to be in a field of the vector space, and we call it a closure property of scalar multiplication. Okay. And the third one is also about the basic operator of the vector. And the third here is if you have any U, vector U plus vector V, it has to be equal to V plus U, or we can say that it is the commutative law of addition. Commutative law of addition. And the fourth, we have U, the vector U plus V plus W, where the bracket here in the second term, and the bracket has in the first term, in the second, U plus V plus W, it have to be equal, and we can call it as associative law of addition. And then we have a zero number here, or we can say the zero number in an addition operation as identity element. So we have the identity element here. So if we add any factor with the identity element, it have the result. It have to be resulted that's own factor number. So it has to be V identity element plus V, it has to be the factor V, or identity V plus identity element have to be V. Have to be the same. So we have the existence of identity element for addition. And then next, the number 6, we have what we call as additive inverse. Here is the inverse of U. so it has to be equal to 0, and it's also the inverse is same. It's only change the position. It's in the second term, and then one in the first term, and we call it the existence of additive inverse. Okay, then we have the scalar multiplication operation, where we just times A times U, A times V, so it has to be AU plus AV, and we know it as a distributive law of scalar multiplication. Then we have A plus B times U, so it's the times on as usual, AU plus BU. I'm sorry that I have to tell you that the meaning of A and B here, they have to be in the real number, as well as the U plus or V or W, it has to be in vector space. Okay, then this operation, you can call it as a multiplication of addition. So we have the result like this, has to be equal to AU plus BU, and 9 is A B times U, it has to be A bracket in BU, has to be equal, right? So we can forget this operation, because this operation, all this operation will derive the result of the vector space. So we can say that this operation is associativity of scalar multiplication. And then if we have an identity element in addition operation, we have the identity element for the scalar multiplication. So it means that any U or any V vector, if we times with the identity element, it will be its vector own self. So 1 as the identity number of times U, it will be resulted U, and it has to be equal to U. So we can say that it is an identity element property of scalar multiplication. So that is that all. If we see that and analyze all of the property, we have 10 property here. Actually, we have 4 operation for addition. 3, I have 3 up to 6 is addition operation, and 7 up to 10, that is scalar multiplication. So actually vector space is only using the operation, the basic operation with the factor, addition and scalar multiplication, and I think that's easy enough, and I hope that this video can help you to understand this material about the vector space, and thank you.